Okay, today we're looking at question 1H from the MAT 2018 paper, and we are given two triangles, capital S and capital T, and these are inscribed in a circle. And if we denote the areas of these triangles by little s and little t, we are told that they satisfy s is strictly less than t. And the question is to find the smallest value of this function, so 4s squared plus t squared all over 5st. And we've got a few options below. Okay, so we've got our two triangles in our circle, T and S, and the important piece of information we've been given is that S is strictly less than T. So if we think about this, we can actually have these areas to be arbitrary size. As long as they satisfy S is less than T, we can make this circle really large, we can move the nodes of these triangles. So something to help us with this problem we can fix the triangle T, so fix the area of T as little t, and then we can think of varying the area of S by just moving this node here. So if we pick this node up and we move it along the circle, we can see that we can make this area to have arbitrary size as long as it satisfies T is less than S is less than T. So another way to think about this is if we draw the segment of the number line between 0 and T, the value of S, it can take any value between 0 and t. So we can think of varying the area of S as long as it's bounded between 0 and t. So then what that allows us to do is we can call this function f of s, so it's just now a variable of s. So we've let t be a constant and we're just varying over the variable s. So what that allows us to do is we can minimize this function in just one variable, and we know how to do that. We can find the derivative, set it equal to 0, and find the minimum like that. So that's what we're going to do. So we can simplify this first, so let's just split this fraction up. 4s squared over 5st, that's the same as 4 over 5 times s over t, and plus t over 5s. So the t's are cancelled. So as we were saying, we're going to find the derivative of this function in s, so f dashed of s. And remember, t is a constant here, so we have s to the power of 1, that vanishes when we differentiate it, 4 over 5 times 1 over t, plus t over 5 is a constant, and we're differentiating 1 over s, which is minus s to the minus 2. So now we want to set this derivative equal to 0 and find the solution. That will give us a turning point. So f dashed of s equals 0. This is the same if we just bring this over to each side of the equation. We have 4 over 5, 1 over t equals minus, that goes to the other side, so we have t over 5s squared. And now we see the 5's cancel, and we can cross multiply the t and the s squared, and we're going to be left with 5s squared equals 4s squared equals t squared. And then this is fairly simple. We divide by 4 and take the square root, and this gives us the solution t over 2. So s equals t over 2. And this is good because it satisfies our condition. This is in between 0 and t, it's t over 2, it's right in the middle. And this point is the turning point. So what's left to do is verify it's a minimum and to find the value of this function at this point. So to verify it's a minimum, we can find the second derivative of this function and check that it's positive at this point. So to do that, we find the second derivative, we just differentiate this expression. Now this little constant here, this is a constant, so when we differentiate it, it's going to vanish. And then we just need to differentiate this expression. So we bring down the power of minus 2, and that cancels with this negative sign. And we're going to have t over 10 times s to the minus 3. And we can see since this value of s is positive, then the second derivative is going to be positive at this point. So that tells us this point is a minimum of this function in this range. So what's left to do is just evaluate this function at this point. So f of t over 2, wherever there's an s, we just put t over 2. So 4 over 5, 1 over t, and then the value of s, which is t over 2, plus t over 5 times 1 over s, so 1 over this expression, which is 2 over t. And it's very convenient because the t's cancel, and we're just going to get left of a number. So we'll have 2 over 5 plus 2 over 5, which is 4 over 5. So this gives us, just to summarize, this gives us the minimum value of this expression when these two triangles satisfy this condition, s is less than t.